Hello, this is Mr. Stansbury. I'm going to take you through the notes on conditional probability. At the end of this, you should be able to say, I understand and can apply the conditional probability formula to find the probabilities of various scenarios. Okay, so first thing, the conditional probability of an event B is the probability that the event will occur given the knowledge that event A has already occurred. Okay, so this is written as P, probability of B, given that A happened. Okay, I'm going to take you through some examples here, but I'm going to explain this formula here first to you. So here's what it looks like, probability B given A. So that's going to be the probability, easiest way to look at this is probability of A. So you're only choosing from this this group A here. So we'll call this as A, and this is also A. So you're only choosing from this group A, and what's the probability that from that group A, B also happened? That's what this is saying. Probability of B happening given that A already did happen. Okay, so let's look at some examples, and that will should help clarify. So, example 1, in Shamrock, Texas, 77% of the residents own sandwich sandals, 62% own fish flops, and 13% don't own either. Draw a Venn diagram to describe the situation. So we know we have 13% out here. Let's just do this all out of 100. So we know there's 100 total percent in here. So 13 don't do either. We know that, let's see, let's do the sandwich sandals and the fish flops over here. So we know that there are 77 that do sandwich sandals and 62 that do fish flops. And there's 13 that don't do either. So what we want to do is we have 100 minus 13. We know that there's going to be 87 total in these three regions right here, right? But if we take 77 and 62, add those together, that's going to give us a big number, 139. That'd be, if it was just 62 here and just 77 there, there'd be 139 total. We know that can't happen. So what we want to do is take that 139, subtract, we know there can only be 87 total in there, so we subtract those from each other, and we get 52. That means 52 people got counted twice, so that means 52 people own both. So 52 are already in this circle here, and there's 77 total in this circle. That means 15 plus 52 will give us 77. And then over here there's 62 total in the circle. We've got 52 already there, and that would make that 10 that own just fish flops. Okay, so now that we have this all figured out, that's what's going to help us understand this conditional probability a little bit better. So first, find the probability that a randomly selected resident owns both. So that is going to be our 52 out of 100, right, which is 52%. Find the probability that a randomly selected student owns only fish flops. So only fish flops would be this one. There's 62 that own fish flops, but 52 of those 62 also own sandwich sandals. So that is 10 out of our 100, which is 10%. Okay, and then now here's where we're getting into our conditional probability piece. What's the probability? Find the probability that a randomly selected resident owns sandwich sandals given that they own fish flops. So for this here, here's the key. Given that they own fish flops. So we're only selecting from this circle right here. This 15 and 13 over here we don't care about, because we're saying that we're selecting from the people that own fish flops. So that is 62 of these total people. So of those 62 people, how many of them also own sandwich sandals? So those 52 out of 62 also own sandwich sandals. Okay? All right. That calculates out to 83.9% if you want to keep leaving things in percent, or you can leave it in a fraction. That's fine too. Find the probability that a randomly selected resident doesn't own fish flops given that they own sandwich sandals. So now we're given that they own sandwich sandals. So we're only choosing from these 77 people. So let's do that down here where we have more room. So we're choosing of these 77 people right here, how many of them also do not own fish flops. So it's only these 15 because these 52 do own fish flops. These 15 do not. So it's going to be 15 out of 77. All right, and that's 19.5%. All right, one last example, but before we do that, let's do a comedy break.
She gives him the phone. He has no idea there's a camera in there. He's just whipping it all over the place. I'm seeing his face zip by at the speed of light. I'm yelling, "Stop moving the phones! Aim it in one place!" He thinks it's for audio reasons. He aims it at the corner of his room. I'm seeing a cobweb dangling. "Can you hear me?" "I always could hear you. Aim it at your face, Dad." So he sort of gets it, but not really. It's like two unfocused eyes. They don't know where to look. Like an alligator coming out of a swamp at a 45-degree angle. I'm like, "Hey, Dad, how you doing?" "Who is this?" "It's Brian." "Who am I talking to?" I felt bad until he asked, "Who's that in the square up in the corner?" "That's you, Dad." "No, there's somebody in the corner looking at us."
All right. Let's look at our last example here. Example 22. Elise has two shelves with Pringles on them. The top shelf has 5 paprika-flavored Pringle cans and 3 ketchup-flavored Pringle cans. On the bottom shelf, she has 3 paprika cans and 7 ketchup cans. Elise is 3 times more likely to take a can from the top shelf. If Elise takes a can at random, find the probability that it is paprika flavored or was taken from the bottom shelf, given that it's ketchup flavored. Okay, so made a tree diagram just to kind of help figure this out, make it a little bit easier. So it says she has, let's see, 3 times. She's 3 times more likely to take a can from the top shelf. So that means 3 out of 4 times she's going to reach from the top shelf. And only 1 out of 4 times she's going to reach from the bottom shelf, because 3 times. So if she chooses 4 times, 3 of those 4 times from the top, one of the 4 from the bottom, right? On the top shelf, there are, let's see, 5 paprika, and there are, 3 ketchup flavored. So there's 5 out of 8 is paprika, 3 out of 8 is ketchup. And on the bottom shelf, let's see. Bottom shelf, she has 3 paprika cans and 7 ketchup cans. So 3 and 7 for a total of 10 each. 10 on the bottom shelf. Okay, so now we've got this all set up. Should make these questions significantly easier. So she chooses, at least takes a can at random, find the probability that is paprika flavored. Okay. So that means it could be the top shelf paprika or it could be the bottom shelf paprika. So it could be either one of these, right? So that's going to be 3/4 times 5/8. And then also it could be 1/4 times 3/10. Okay? Okay. So calculated these out. And we get 46.9% for taking a paprika flavored can from the top shelf and 7.5% from getting a paprika can on the bottom shelf. So if we add those two together, 46.9% plus 7.5%, that's going to give us 54.4% chance. Okay? Now, part B says, find the probability that it was taken from the bottom shelf, given that it's ketchup flavored. So now we're only talking about, we know for sure that it was ketchup flavored. So it's this one and this one. Okay, so we got to figure out those two. Okay, now here's the key. Look, we already figured out these two. All 4 of these always have to add up to 100%. So we already got 54.4. So let's do 100 minus 54.4. Right? So 100 minus 54.4 gives us 45.6%. So we know that there's only a 45.6% chance of taking it from the bottom shelf. So what? Oh, sorry, of taking a ketchup flavored can. So what was the probability that it was from the bottom shelf? So that would be this one here. So that would be the 1/4 times 7/10, right? Which is 7/40. So if we do that one, 7/40, we get 17.5. Right, so we would need to take 17.5 and divide it by 45.6. So take that divided by 45.6, and we get, oh, rats, I did that wrong. So let's do 17.5 divided by 45.6. There we go. That'll give us a little bit better answer. 38.4%. 38.4% chance that the randomly selected can was taken from the bottom shelf, given that it was ketchup flavored. Okay? All right. That's all there is for conditional probability. If you have any further questions, please feel free to ask in class. Thanks.